November 30th, 1942. 2,316 hours. Iron Bottom Sound, off Tassafaronga, Guadalcanal. Task Force 67, United States Navy. Steam through darkness with confidence born of recent victories. Rear Admiral Carlton H. Wright, 53 years old, from Chagrin Falls, Ohio, commanded 5 heavy cruisers and 4 destroyers, overwhelming firepower by any conventional calculation. USS Minneapolis flagship, USS New Orleans, USS Pensacola, USS Honolulu, USS Northampton. Combined displacement, 50,000 tons. Combined main battery, 45 8-inch guns, 65-inch guns. Their mission, intercept Japanese Tokyo Express destroyer run attempting to resupply isolated garrison on Guadalcanal. Intelligence reported 8 Japanese destroyers carrying supplies in drums that would be pushed overboard for retrieval by shore parties. Wright's force represented crushing superiority. 5 heavy cruisers against 8 destroyers. Destroyers designed for screening operations, not surface combat with capital ships. American radar had detected Japanese formation at 2,306 hours, range 23,000 yards. Wright's cruisers turned to unmasked broadside batteries, preparing to deliver devastating salvos that would annihilate Japanese force before they could even respond. What Wright did not know, what no American naval officer could have known in November 1942, was that those 8 Japanese destroyers carried weapon systems so advanced, so devastating, so far beyond anything in Western naval arsenals that would reverse every tactical assumption about destroyer versus cruiser combat. Rear Admiral Reizo Tanaka, 54 years old, from Yamaguchi Prefecture, commanded Japanese Destroyer Squadron 2 from flagship Naganami. 8 destroyers, Naganami, Takanami, Mekanami, Kuroshio, Yashio, Kadro, Suzuki's Kawakaze. Combined displacement, 14,400 tons, less than 1/3 American tonnage. But each destroyer carried 8 Type 93 torpedoes. The Long Lance, pure oxygen propulsion, no wake, no bubbles, no warning. Range, 40,000 yards at 36 knots, 22 statute miles. Warhead, 1,080 pounds of Type 97 explosive, twice the explosive content of American torpedoes. Diameter, 610 millimeters, 24 inches, largest torpedo in service with any Navy. Speed options, 49 knots at 22,000 yards, 36 knots at 40,000 yards. In the next 12 minutes, Tanaka's 8 destroyers would demonstrate why the Long Lance was the most lethal torpedo system deployed by any Navy in World War II. In those 12 minutes, for American heavy cruisers would be crippled or sunk. In those 12 minutes, American naval doctrine regarding destroyer capabilities would be shattered. In those 12 minutes, the Battle of Tassafaronga would reveal a technological gap that U.S. Navy had not known existed. Gap that would take 18 months of desperate analysis to understand and counter. Type 93 torpedo development began in 1928, when Imperial Japanese Navy recognized fundamental limitation of all contemporary torpedo technology: compressed air propulsion. Every Navy in world, British, American, German, Italian, French, used compressed air torpedoes with same basic limitations. Visible wake. Compressed air mixed with seawater created highly visible wake of bubbles trailing torpedo. Targeted ships could see torpedoes coming, take evasive action. Limited range. Compressed air tanks limited torpedo range to 6,000 to 10,000 yards maximum at combat speeds. Speed range trade-off. Higher speeds consumed air faster, dramatically reducing range. Lower speeds increased range but reduced hit probability. Limited warhead size. Compressed air tanks occupied substantial internal volume, limiting space for explosive warhead. Japanese naval planners, studying lessons from World War I and analyzing capabilities of potential adversaries, concluded that Japan faced fundamental strategic problem: geographic disadvantage. Japan's island geography meant any naval conflict with the United States would occur far from Japanese home bases. American fleet would operate from Pearl Harbor, Philippines, eventually captured island bases closer to Japan. Numerical inferiority. Washington Naval Treaty, 1922, limited Japan to 60% of American/British capital ship tonnage. In any Pacific War, Japan would be outnumbered. Resource limitations. Japan lacked industrial capacity to match American ship production. Every engagement would be attritional warfare Japan could not sustain. Solution required weapon system that could achieve decisive results in single engagement. Weapon that could sink superior numbers of enemy ships before they could bring superior firepower to bear. Answer: torpedo that could strike from beyond visual range, without warning, with devastating warhead. Requirements seemed impossible with existing technology. Range 40,000 plus yards, beyond visual range at night, beyond effective gunfire range. High speed, 40 plus knots to minimize target evasion time. Large warhead, sufficient to sink battleship or cruiser with single hit. No visible wake, preventing evasive action. Reliable gyroscope guidance, maintaining course over extreme ranges. Compressed air technology could not meet these requirements. Physical limitations of compressed air made extended range impossible without sacrificing speed or warhead size. Japanese engineers focused on alternative propulsion, pure oxygen instead of compressed air. Theoretical advantages were enormous. Chemical efficiency. Pure oxygen combustion with kerosene fuel produced 2 to 3 times energy output compared to compressed air combustion. No visible exhaust. Pure oxygen combustion with kerosene produced only carbon dioxide and water vapor, both completely soluble in water. No bubbles, no wake. Reduced tank size. Higher energy density meant smaller fuel/oxidizer tanks for same range, allowing larger warhead or extended range. Higher speed sustainable. Efficient combustion allowed high speeds over long ranges without depleting oxidizer supply. Practical challenges were equally enormous. Oxygen instability. Pure oxygen is extraordinarily reactive. Any contamination with oil, grease, organic matter, or certain metals could trigger spontaneous explosion. Pressure containment. Storing oxygen at 140 to 150 atmospheres pressure in torpedo-sized container while preventing leaks or ruptures. Combustion control. Regulating pure oxygen feed to maintain steady combustion without detonation. Manufacturing precision. Entire torpedo system required absolute cleanliness. Single speck of oil could cause catastrophic explosion during loading or launch. Safety protocols. Personnel handling torpedoes required extensive training, special clothing, rigorous cleaning procedures. Western navies had examined pure oxygen torpedoes during 1920s to 1930s. All concluded risks outweighed benefits. Several experimental programs terminated after fatal explosions. British Royal Navy. Experimental pure oxygen torpedo program 1924 to 1927 resulted in 3 fatal accidents. Program canceled 1927. United States Navy. Bureau of Ordnance examined pure oxygen propulsion 1926 to 1928. Concluded technology was impractical for service use due to excessive danger in handling and storage. No prototype built. German Kriegsmarine. Limited research 1930 to 1933. Concluded compressed air torpedoes with improved propellants offered better balance of performance and safety. Imperial Japanese Navy took opposite conclusion. Risks were acceptable if technology provided decisive tactical advantage. Development program began 1928 under direction of Captain Toshihide Asakuma, 47 years old, torpedo specialist with engineering background from Naval Technical Department. First 5 years saw repeated catastrophic failures. Test firings at Yokosuka Naval Arsenal. June 1929. First oxygen torpedo prototype exploded on launch rail, killing 2 technicians, injuring October 7, 1929. Second prototype exploded during fueling, killing 1 technician March 1930. Third prototype ran erratically, circled, nearly struck test ship July 1930. Fourth prototype achieved successful straight run but exploded on impact with target. Premature detonation, November 1930. Fifth prototype leaked oxygen, created visible bubble trail. Each failure required months of analysis, design modifications, new prototype construction. Key technical problems. 1. Oxygen purity. Even 99.5% pure oxygen insufficient. Contaminants cause combustion instabilities. Solution required 99.9% plus purity, achievable only through multiple stage distillation. 2. Material selection. Standard brass fittings used in compressed air torpedoes reacted explosively with pure oxygen. Required development of oxygen-compatible alloys, certain stainless steels, aluminum, bronze. 3. Valve design. Standard valves leaked at high pressures. Required completely new valve designs with metal-to-metal seals. No gaskets. Rubber gaskets reacted with oxygen. 4. Combustion chamber. Initial designs experienced detonation rather than controlled combustion. Required development of combustion chamber geometry that prevented pressure wave propagation. 5. Gyroscope stability. Long-range operation required gyroscope maintaining heading accuracy over 40-plus minutes running time. Existing gyroscopes drifted unacceptably over such periods. By 1932, program had consumed enormous resources with limited success. Naval General Staff considered cancellation multiple times. Captain Asakuma argued persistence. We are solving problems no other navy has solved. When we succeed, we will possess weapon no enemy can counter. Before we continue with how pure oxygen propulsion created invisible torpedoes that traveled 22 miles and why American cruisers at Tassafaronga never saw what destroyed them. If you're fascinated by these stories of secret weapons that provided decisive technological advantage through revolutionary engineering, subscribe and hit notification bell. We publish deeply researched military history documentaries every week that bring you the technological breakthroughs that changed naval warfare forever. Now back to 1933, and the torpedo that would dominate Pacific naval battles for 18 months before U.S. Navy even understood what they were facing. Type 93 entered combat December 8, 1941, December 7 Pearl Harbor time, when Japanese forces launched coordinated attacks across Pacific. First major surface action. Battle of Java Sea, February 27, 1942. Combined Allied fleet, American, British, Dutch, Australian, under Dutch Rear Admiral Karel Doorman, attempted to intercept Japanese invasion convoy heading for Java. Allied force. 2 heavy cruisers, HMS Exeter, USS Houston. 3 light cruisers, 9 destroyers. Japanese force. 2 heavy cruisers, Nachi Aguro. 2 light cruisers, 14 destroyers. Surface action began 1,616 hours at long range, 28,000 yards. Both sides opened fire with main batteries. Japanese cruisers fired accurate salvos despite extreme range, demonstrating superior optical range finding. 1,727 hours. Japanese destroyer Asagamo launched Type 93 torpedoes from approximately 30,000 yards. Allied forces detected no torpedo launch, no visual indication, no wake visible. 1,728 hours. Dutch light cruiser HNLMS de Ruyter struck by single torpedo, 180 feet aft bow. Explosion broke ship's back. De Ruyter sank within minutes, taking Admiral Doorman down with ship. 1,729 hours. Dutch light cruiser HNLMS Java struck by single torpedo amidships. Massive explosion. Ship listed heavily. Sank within 30 minutes. 2 cruisers destroyed by torpedoes that traveled 30,000 yards without detection. Allied survivors reported complete surprise. No one saw torpedo wakes. No warning before explosions. USS Houston's captain, Albert Rooks, reported, ships simply exploded without warning. We observed no torpedo wakes, heard no warnings. One moment cruisers were maneuvering normally, next moment they were sinking. Most catastrophic defeat in U.S. Navy history occurred when Japanese cruiser force surprised American screening force off Guadalcanal. August 9, 1942, 0130 to 0230 hours. Savo Island, Solomon Islands. Vice Admiral Genichi Mikawa commanded Japanese force. 5 heavy cruisers, Chokai, Aoba, Keiko, Kinagasa, Furitaka, 2 light cruisers, Tenryu, Yubari. Destroyer Unagi. Mission: attack American amphibious forces unloading Marines on Guadalcanal beaches. American screening force. 3 heavy cruisers, USS Astoria, Quincy, Vincennes, 1 heavy cruiser, HMAS Canberra, Australian, 2 light cruisers, 8 destroyers. 0143 hours. Japanese aircraft drop flares illuminating American ships. 0143 to 0146 hours. Japanese cruisers opened fire, simultaneously launched Type 93 torpedoes. American forces, caught completely by surprise and rest condition, many crew asleep, ships not at general quarters, struggled to respond. After Savo Island, U.S. Navy began analyzing pattern of unexpected torpedo hits. Ships struck by torpedoes from angles that made no sense given observed enemy positions. Torpedoes that arrived 5 to 10 minutes after enemy ships observed, suggesting impossibly long range. Complete absence of torpedo wakes despite clear visibility conditions. Massive explosions suggesting warheads far larger than American torpedoes. Commander-in-Chief Pacific Fleet Sink Pack. Intelligence staff compiled reports from survivors, analyzed Japanese tactics, attempted to understand how Japanese were achieving such devastating torpedo results. Initial theories, all wrong. Theory 1. Submarine cooperation. Perhaps Japanese submarines were coordinating with surface forces, launching torpedoes from positions American forces didn't detect. Analysis. No submarine periscopes or wake tracks observed. Timing of hits matched surface force movements, not submarine positioning. Theory 2. Superior torpedo guidance. Perhaps Japanese torpedoes had advanced guidance systems allowing long-range homing. Analysis. Torpedo impacts occurred where targets had been when torpedoes launched, not where targets maneuvered afterward. No evidence of homing behavior. Theory 3. Multiple torpedo types. Perhaps Japanese were using different torpedo types for different ranges. Lightweight long-range weapons plus heavy short-range weapons. Analysis. All torpedo hits showed similar explosive characteristics. No evidence of multiple weapon types. Theory 4. Better range finding/fire control. Perhaps Japanese optical range finding was simply more accurate than American radar-based systems at night. Analysis could explain accurate gunfire, but didn't explain torpedo range or absence of wakes. None of these theories explain fundamental mystery. Japanese torpedoes appear to 3-4x the range of American torpedoes, with far larger warheads and no visible wakes. U.S. Navy intelligence concluded, Japanese torpedo technology appears significantly more advanced than we believed. Exact capabilities remain unclear. Further analysis required. But further analysis would require recovering intact Japanese torpedo, something that wouldn't occur until late 1943. Imperial Japanese Navy maintained extraordinary security around Type 93. Torpedo designated Type 93 only in classified documents. Publicly called Special Torpedo or simply Torpedo with no distinguishing designation. Specifications never written in documents that might be captured. Field manuals described Standard Destroyer Torpedo without performance data. Personnel handling Type 93 sworn to absolute secrecy. Officers and crew told that disclosure torpedo capabilities would result in court-martial and execution. Damaged torpedoes scuttled or destroyed rather than abandoned where they might be recovered by enemy. Ships carrying Type 93 had orders to destroy torpedo mounts if capture seemed imminent, preventing torpedo examination. Even Japanese officers not directly involved with torpedo operations were not informed of true capabilities. Many Japanese cruiser and battleship officers believed destroyer torpedoes had approximately same range as their own ship-launched torpedoes, 10,000 to 15,000 yards. This compartmentalization meant Allied intelligence interrogating captured Japanese personnel learned nothing. Most captives genuinely didn't know specifications. Documents captured from Japanese ships contained no technical data even. When Americans captured Japanese torpedoes that failed to explode, damage from water immersion rendered them useless for analysis. By November 1942, U.S. Navy still had no clear understanding of Type 93 capabilities. Intelligence estimates suggested range possibly 15,000 to 20,000 yards, estimates based on observed torpedo hits, but still dramatically underestimated actual 40,000-yard capability. Warhead, possibly 800 to 1,000 pounds, closer to reality, based on explosion damage. Wake, possibly reduced wake through unknown propulsion method, correct conclusion, but no understanding of oxygen system. These estimates, while improving, still dramatically underestimated weapon Americans were facing. By late November 1942, Guadalcanal campaign had reached critical phase. Marines held Henderson Field airfield, but Japanese garrison remained strong, supplied by nightly destroyer runs called Tokyo Express or Rat Run. Japanese destroyers would race down the slot, New Georgia Sound, arrive off Guadalcanal after dark, push supply drums overboard for recovery by shore parties, depart before dawn to avoid American air attack. U.S. Navy Task Force 67 mission. Intercept Tokyo Express run night of November 30/December 1st. 2,306 hours. USS Minneapolis radar detected Japanese formation, range 23,000 yards, bearing 315 degrees. Admiral Wright ordered formation to turn northwest. Unmasked broadside batteries. Prepare to engage. American tactical plan. Close to 10,000 to 12,000 yards. Optimal range for 8-inch guns at night. Illuminate targets with searchlights and star shells deliver overwhelming salvo from 45 8-inch guns destroy Japanese destroyers before they could launch torpedoes. American doctrine. Assume Japanese torpedo range similar to American Mark 15, approximately 6,000 to 8,000 yards at combat speed. Japanese tactical plan. Tanaka's standing doctrine. Detect enemy through superior night optics turn unmasked torpedo tubes, 8 per destroyer, 64 total. Launch torpedoes from maximum range, 20,000 plus yards. Reverse course. Withdraw at maximum speed before enemy close the gunfire range. 2,316 hours. Admiral Tanaka, observing American formation through excellent night binoculars, confirmed American cruisers turning to engage, estimated range 22,000 yards. Tanaka ordered, "All ships, prepare for torpedo action. Launch on my command." 2,317 hours. Admiral Wright ordered, "Open fire when ready." USS Minneapolis fired star shells, illuminating Japanese destroyers. American cruisers opened fire. 8-inch shells bracketing Japanese formation. 2,318 hours. Admiral Tanaka ordered, "Launch torpedoes." 64 Type 93 torpedoes launched simultaneously into darkness. No flash, no smoke, no sound audible to Americans at 20,000 plus yards. No wake visible. Pure oxygen combustion left no bubble trail. Torpedoes ran silently through darkness at 49 knots, covering 1,000 yards per minute. American cruisers continued firing, scoring hits on Japanese destroyer Takanami. Takanami, struck by multiple 8-inch shells, exploded, sank rapidly. Admiral Wright believed engagement proceeding perfectly. One Japanese destroyer sunk. Others appear to be withdrawing. American formation would pursue. Finish off retreating enemy. 2,319 hours. Japanese destroyers executed emergency turn, reverse course, increased speed to 35 knots, withdrawing at maximum speed. American cruisers increased speed to 25 knots, pursuing. 2,320 to 2,327 hours. American formation advanced northwest, chasing Japanese destroyers now rapidly disappearing into darkness. Radar tracked Japanese ships' opening range. American officers discussed whether to continue pursuit or break off engagement. No one suspected 64 torpedoes were running toward them through darkness. 23:27:30 hours. USS Minneapolis, lead cruiser, struck by 2 Type 93 torpedoes. First torpedo struck bow, 50 feet aft stem. Explosion severed bow forward of turret 1. Entire bow section, approximately 50 feet, simply vanished, disintegrated by explosion. Second torpedo struck 20 feet further aft, starboard side. Explosion destroyed compartments, killed 37 sailors instantly. Minneapolis slewed left, out of formation, losing speed rapidly. Fire spread, ship taking water, bow completely gone, but remain afloat through excellent damage control. 23:28:00 hours. USS New Orleans, second in line, struck by single Type 93 torpedo bow. Explosion detonated forward magazine, containing ammunition for turrets 1 and 2. Massive secondary explosion literally severed bow forward of turret 2. Entire forward section, approximately 150 feet. Nearly 1/3 of ship's length broke off, sank within 30 seconds. New Orleans wallowed, down by head, fires raging, but miraculously remained afloat. Damage control teams fought desperately to save ship. 23:29:00 hours. USS Pensacola, third in line, struck by single Type 93 torpedo port side aft near engineering spaces. Explosion destroyed oil tanks, ignited fuel. Massive fires erupted, spread to after magazines. Ship's after section became inferno, killing 125 sailors. Pensacola slowed, turned out of formation, fighting fires that threatened to detonate after magazines. 23:30:00 hours. USS Honolulu, fourth in line, miraculously avoided torpedoes through emergency evasive maneuver by alert commanding officer. Captain Haler, seeing explosions ahead, ordered emergency turn to starboard without waiting for orders. Honolulu's bow swung right. 2 torpedoes passed down port side, missing by 50 feet. 23:32:00 hours. USS Northampton, fifth in line, tail end Charlie, struck by 2 Type 93 torpedoes port side amidships. First torpedo struck engine room, destroyed machinery, killed engineering crew instantly. Ship lost all power. Second torpedo struck fuel tanks, ignited oil. Massive fires erupted, spread throughout ship. Without power for firefighting pumps, fires burned uncontrolled. Northampton listed heavily. Abandoned ship ordered. Cruiser capsized, sank 03:04 hours December 1st. 58 officers and men lost. Battle of Tassafaronga final tally. Japanese losses. 1 destroyer sunk, Takanami. Approximately 150 casualties. American losses. 1 heavy cruiser sunk, USS Northampton. For heavy cruisers crippled, Minneapolis, New Orleans. Pensacola, Required 6 to 12 months repairs. 395 killed, 267 wounded. 5 to 1 cruiser exchange ratio. 5 American heavy cruisers disabled/sunk versus 1 Japanese destroyer sunk. This represented complete reversal of expected outcome. 5 heavy cruisers with overwhelming gunfire superiority have been devastated by 8 destroyers. Even more shocking, damage occurred after Americans believed they had won engagement. Japanese destroyers were withdrawing. Americans were pursuing victorious, when suddenly cruisers started exploding. Admiral Wright's after-action report, December 5, 1942. Enemy destroyers appeared to withdraw after initial exchange of gunfire. Our force pursued. Without warning, lead ships began taking torpedo hits. Torpedoes appeared to arrive 8 to 10 minutes after enemy ships observed turning away. This suggests torpedo range far exceeding our intelligence estimates. No torpedo wakes were observed despite good visibility. Source of torpedoes unclear, possibly submarine cooperation, possibly advanced torpedo propulsion. Sink pack analysis, Admiral Nimitz's staff. Battle of Tassafaronga demonstrates Japanese torpedo capabilities substantially exceed our previous estimates. Evidence suggests torpedo range minimum 20,000 yards, possibly 30,000 plus yards, warhead size approximately 1,000 plus pounds, wake visibility near zero under night conditions, reliability high. Multiple torpedo hits achieved. Japanese appear to possess torpedo technology significantly superior to our own. Urgent requirement to determine exact capabilities and develop countermeasures. After Tassafaronga disaster, U.S. Navy launched intensive investigation into Japanese torpedo capabilities. Bureau of Ordnance, BORD, established special research team. Project Longlands, name given by naval intelligence based on translated intercepted Japanese communications referring to long-reaching torpedo. Primary questions. How were Japanese achieving 20,000 to 30,000 yard torpedo ranges? Why were torpedo wakes invisible? How large were Japanese warheads? What propulsion system enabled this performance? Investigation methodology. Analysis of battle damage. Forensic examination of ships struck by Japanese torpedoes, comparing explosion damage characteristics. Interrogation prisoners. Captured Japanese naval personnel questioned. Yielded almost nothing. Most genuinely did no technical specifications. Those who did refused to talk despite interrogation. Document analysis. Captured documents examined for any reference to torpedo specifications. Japanese operational security meant most documents contained no technical data. Torpedo recovery. Intense effort to recover intact Japanese torpedo for examination. Extremely difficult. Most torpedoes exploded on impact. Those that didn't were damaged by water immersion, destroying internal mechanisms. Theoretical analysis. American torpedo experts attempted to reverse engineer requirements, determine what propulsion system could achieve observed performance. June 15, 1943. Rendova Island, Solomon Islands. U.S. Navy salvage team recovering equipment from beached Japanese destroyer discovered partially intact Type 93 torpedo in ship's magazine. Torpedo had been removed from launch tube for maintenance when ship was abandoned, protected from saltwater immersion, internal mechanisms relatively intact. Torpedo immediately shipped to Naval Torpedo Station, Newport, Rhode Island, for examination. June 18 to 25, 1943. American torpedo experts conducted detailed analysis. Initial findings shocked examination team. Torpedo diameter, 610 millimeters, 24 inches, substantially larger than American 533 millimeters, 21-inch torpedoes. Length, 9 meters, 29.5 feet, longer than American torpedoes. Weight, empty approximately 2,200 kilograms, heavier than American torpedoes despite aluminum construction. Warhead size, estimated 490 kilograms, 1,080 pounds, based on warhead compartment volume. More than double American Mark 15 warhead, 224 kilograms/494 pounds. Propellant tanks. Examination revealed tanks labeled in Japanese characters. Chemical analysis of residue showed pure oxygen and kerosene, not compressed air. This explained everything. Invisible wake. Pure oxygen combustion with kerosene produced only CO2 and water vapor, both completely soluble in water. No bubbles, no visible wake. Extreme range. Pure oxygen provided 2-3x energy density compared to compressed air, enabling 40,000 yard range at 36 knots. High speed. Efficient combustion allowed 49 knots maximum speed. Large warhead. Reduced propellant tank size due to high energy density allowed space for massive warhead. Bureau of Ordnance immediately asked, why had we developed this? Answer was complex, revealing fundamentally different approach to risk assessment between Japanese and American naval establishments. U.S. Navy had examined pure oxygen torpedoes in 1920s, rejected concept as too dangerous. 1926 to 1928 feasibility study by Bureau of Ordnance concluded pure oxygen propulsion offers theoretical performance advantages. However, practical implementation presents unacceptable safety hazards. Oxygen reactivity. Pure oxygen reacts explosively with hydrocarbons, many metals, or organic compounds. Any contamination during manufacture, loading, or storage could cause catastrophic explosion. Personnel safety. Handling pure oxygen torpedoes will require extensive training, special equipment, rigid safety protocols. Any procedural error could kill crew, destroy ship. Industrial capacity. Manufacturing pure oxygen torpedoes will require dedicated facilities with extraordinary cleanliness standards, specialized equipment, extensive quality control. Industrial burden deemed excessive for marginal performance gain. Reliability concerns. Complex propulsion system with multiple failure modes. Compressed air torpedoes. While limited in performance, highly reliable. Recommendation. Continue development of improved compressed air torpedoes rather than pursuing high-risk pure oxygen technology. This recommendation, approved by Chief of Naval Operations, became U.S. Navy policy. Japanese Navy reached opposite conclusion. Accept safety risks. Benefits outweigh dangers. Invest resources in specialized manufacturing facilities. Long-term capability worth short-term cost. Train personnel to extreme standards. Proper training mitigates safety risks. Accept lower reliability initially. Iterative development will improve reliability over time. Different naval doctrines, different risk tolerance, different conclusions. American philosophy. Avoid unacceptable risks. Maintain operational safety. Accept performance limitations. Japanese philosophy. Accept risks if benefits provide decisive tactical advantage. Invest whatever resources necessary to achieve superior performance. Understanding Type 93 capabilities allowed U.S. Navy to develop effective countermeasures. Tactical changes implemented mid-1943. 1. Assume all Japanese surface ships can launch torpedoes to 40,000 yards. Previous doctrine assumed only torpedo attacks came from ships within visual range, 10,000 to 15,000 yards. New doctrine. Treat any Japanese ship within 40,000 yards as potential torpedo threat. 2. Aggressive evasive maneuvers immediately upon detecting Japanese ships. Begin radical course changes immediately. Don't wait to identify threat or confirm torpedo launch. 3. Never pursue withdrawing Japanese destroyers. Tassafaronga taught. Withdrawing, Japanese destroyers had just launched torpedoes. Pursuing meant steaming into torpedo field. 4. Use destroyers as torpedo screens. Station destroyers ahead of cruisers/battleships. Destroyers more maneuverable, better able to avoid torpedoes. 5. Radar-directed night gunnery from maximum range. Use radar advantage to engage Japanese ships from 20,000 to 25,000 yards, beyond their optical range-finding capability, before they could launch torpedoes. Technological responses. Improved radar. Development of fire control radar, allowing accurate gunnery at night, without visual observation. Americans can now engage targets Japanese couldn't see, reversing night combat advantage. Proximity fuse shells. VT variable time. Proximity fuse for 5-inch shells made anti-aircraft fire and surface gunnery far more effective. Faster ships. Essex-class carriers, Iowa-class battleships, and later cruisers built for 32 to 33 knot speed, allowing them to outrun torpedoes or quickly maneuver out of torpedo fields. Better damage control. Improved compartmentalization, better firefighting equipment. Trained damage control parties reduce vulnerability to torpedo hits. Last major surface engagement of Pacific War demonstrated how completely American countermeasures had negated long lance advantage. Japanese Southern Force, Vice Admiral Shoji Nishimura. 2 battleships Yamashiro. Fuso, 1 heavy cruiser Mogami for destroyers. Mission: force passage through Surigao Strait. Attack American amphibious forces at Leyte Gulf. U.S. 7th Fleet, Rear Admiral Jesse Oldendorf. 6 battleships, 5 Pearl Harbor survivors. West Virginia, Maryland, Tennessee, California, Pennsylvania, plus Mississippi. 8 cruisers, 28 destroyers, 39 PT boats. Battle proceeded with American forces, using perfect defensive position. PT boats harassed Japanese force as it entered Strait, Reporting positions. Destroyers. Launched torpedo attacks from both flanks as Japanese force advanced through Strait. American torpedoes less capable than Type 93. But attacking from close range in confined waters, they achieved multiple hits. Battleships. Positioned in line across the northern X of Strait, crossing the T. Classic naval maneuver allowing all American battleships to fire full broadsides at Japanese ships that could only return fire with forward guns. Radar-directed fire. American battleships opened fire at 22,800 yards beyond Japanese optical range-finding capability in darkness. Japanese ships, unable to determine range to targets they couldn't see clearly, fired ineffectively. Japanese destroyers attempted long lance attacks, but confined waters of Strait limited maneuver space. American destroyer attacks disrupted Japanese formation. American radar detected Japanese destroyers. Concentrated fire destroyed them before they could launch effectively. Some Type 93 torpedoes launched, but American ships detected them on radar, maneuvered successfully. Result: complete American victory. Japanese losses. Both battleships sunk. Yamashiro Fuso. One heavy cruiser sunk. Mogami scuttled after damage. 3 destroyers sunk. Approximately 2,800 killed. American losses. Minor damage to several destroyers. 39 killed. This represented complete reversal from Tassafaronga 2 years earlier. Long lance no longer provided decisive advantage. American radar. Superior numbers. Tactical adaptations had negated Japan's technological edge. Type 93 production statistics. Japanese records captured in 1945. Total production 1933 to 1945. Approximately 3,500 torpedoes. Production by year. 1933 to 1937. 120. Development/testing. Limited production. 1938-1941. 450. Pre-war buildup. 1942. 680. Peak wartime production. 1943. 620-1944. 380. Declining due to resource shortages. Factory bombing. 1945. 250. January-August only. Deployment. Type 93 issued primarily to heavy cruisers, 8 to 16 torpedoes, depending on class. Light cruisers, 8 torpedoes. Destroyers, 8 to 16 torpedoes, depending on class. Notable platforms. Fubuki-class destroyers, 9 torpedo tubes. 1 reload per tube equals 18 total torpedoes. Kajiro-class destroyers, 8 torpedo tubes. 1 reload equals 16 total. Mogami-class cruisers, 12 torpedo tubes, no reloads. Tone-class cruisers, 12 torpedo tubes. Manufacturing. Torpedoes manufactured at Kure Naval Arsenal, Yokosuka Naval Arsenal, Sasebo Naval Arsenal. Specialized facilities required. Oxygen production/purification plants, ultra-clean, assembly buildings, air-filtered, humidity-controlled. Specialized testing facility, storage magazines with temperature/humidity control. Quality control. Each torpedo required. 1. 200-plus man-hours to manufacture 300-plus individual parts machined to extreme tolerances, multiple inspection stages, full-function testing before delivery. Cost. Approximately 3x cost of conventional compressed air torpedo. Casualties inflicted. Type 93 confirmed sinking/major damage. U.S. Navy Historical Center analysis. Capital ship sunk. Heavy cruisers, 6 Canberra, Astoria, Quincy, Vincennes, Northampton, plus Indianapolis. Sunk by submarine launch Type 95, oxygen torpedo variant. Light cruisers, 3 De Ruyter, Java, Juno. Destroyers, 14. Capital ships crippled, 6+ months repair. Heavy cruisers, 8 Minneapolis, New Orleans, Pensacola, Chicago, Houston, Boise, others. Light cruisers, for destroyers, 23. Personnel casualties. Killed, approximately 5,800 U.S./Allied sailors wounded, approximately 3,200. Tonnage sunk. Approximately 115,000 tons of Allied warships sunk or crippled by Type 93 torpedoes. This made Type 93 one of the most effective weapon systems deployed by Japan during Pacific War. More tonnage sunk than achieved by Japanese aircraft carrier strike aircraft. More tonnage than Japanese submarines. More tonnage than Japanese battleship main batteries. Discovery of Type 93 capabilities catalyzed major revision of U.S. torpedo development. Mark 15 torpedo, standard U.S. destroyer torpedo 1942 to 1943, problems. Range, 15,000 yards maximum at reduced speed 26 knots, inadequate compared to Type 93's 40,000 yards warhead. for 194 pounds, less than half Type 93's 1,080 pounds wake, highly visible compressed air wake speed, 26 knots maximum, significantly slower than Type 93's 49 knots. Even worse, Mark 15 suffered from reliability problems, depth-keeping issues, ran too deep, passing under targets, magnetic exploder failures, detonating prematurely or not at all, contact exploder failures, failing to detonate on impact. These problems meant many American torpedoes that should have hit targets failed to explode. Bureau of Ordnance Response, 1943 to 1945. Immediate fixes. Disabled magnetic exploders, too unreliable. Fixed contact exploder mechanisms corrected depth-keeping problems. Long-term development. Mark 16 Torpedo, 1943 improved compressed air torpedo with better range, 11,000 yards at 46 knots. Larger warhead, 825 pounds, but still visible wake. Mark 18 electric torpedo, 1943 copied from recovered German G7E electric torpedo. Wakeless electric propulsion, but slow, 29 knots, limited range 4,000 yards. Used primarily by submarines. Mark 27 acoustic homing torpedo, 1943 guided torpedo for anti-submarine use. Not surface warfare application. Oxygen torpedo development, 1944 to 1945 board initiated crash program to develop American oxygen torpedo based on Type 93 analysis. Program faced same challenges Japanese had overcome 1928 to 1933. Oxygen purity requirements, material compatibility, issues, safety, protocols, manufacturing complexity. By August 1945, war's end, American oxygen torpedo program had developed working prototypes, demonstrated ranges exceeding 30,000 yards, not yet reached production stage. Program canceled August 1945 when war ended. U.S. Navy concluded oxygen torpedoes provide performance advantages, but peacetime safety considerations and development of guided missiles make them unnecessary. Future anti-ship weapons will be air-launched guided missiles with longer range and greater accuracy than any torpedo. Type 93 represented rare case of Axis power, achieving genuine technological superiority over Allies in major weapon system. Most World War II weapon systems showed Allied superiority or parity. Radar, Allied lead, especially British-American, sonar, Allied lead cryptography, Allied lead Enigma broken, Japanese codes broken aircraft, generally Allied superiority by 1943 to 1944 tanks, rough parity, with advantages on both side artillery, generally Allied superiority, especially U.S., small arms, rough parity. Type 93 was exception, genuine, substantial Japanese technological lead that lasted 18 months before Allied understanding and countermeasures negated advantage. Comparison to other wonder weapons. German V-2 rocket. Technologically impressive but militarily ineffective. Minimal damage relative to cost. German Type XXI U-boat. Potentially war-changing but arrived too late, too few. German jet aircraft. Potentially important but insufficient numbers. Arrived too late. Japanese Type 93. Actually effective. Actually inflicted significant casualties. Actually forced major tactical adaptations by enemy. Type 93 was genuinely effective weapon that provided real advantage. Until countermeasures developed. Captain Toshihide Asakuma, Development Director 1928 to 1936. Survived war. Post-war interview 1952. We knew oxygen torpedo was dangerous. We had accidents, deaths during development. But we also knew if we succeeded, we would give Japan weapon no enemy possessed. That was worth the risk. When I heard reports from Tassafaronga, American cruisers destroyed by torpedoes they never saw, I felt vindication. We had created a weapon that could defeat superior enemy force. For a brief period, our technological achievement gave Japan fighting chance. Asakuma died 1967, age 86. Rear Admiral Reizo Tanaka, tactical innovator. Tassafaronga victor. Survived war. Post-war wrote extensively about destroyer tactics and Type 93 employment. Long lance gave us capability Americans could not match. But weapon alone could not win war. Once Americans understood what we had, they adapted. Their industrial power overwhelmed our technological edge. Type 93 was magnificent weapon, best torpedo of war. But magnificent weapon cannot overcome strategic disadvantages. Tanaka died 1969, age 77. Captain Tamichi Hara, destroyer commander, Naganami. Survived war. Wrote memoir, Japanese Destroyer Captain, published 1961, describing Type 93 operations. Americans called it Long Lance. We simply called it Type 93. To us, it was tool, dangerous tool requiring careful handling, but tool nonetheless. We knew its capabilities. We knew its limitations. We used it effectively when tactical situation favored its employment. After 1943, tactical situations rarely favored us. American radar, American numbers, American industrial power negated our advantages one by one. Hara died 1980, age 75. U.S. Navy never expected Japanese torpedoes to travel 40,000 yards because Western naval establishments had concluded oxygen propulsion was too dangerous to pursue. Japanese Navy accepted the risks, invested the resources, solved the problems, and created a weapon system that dominated Pacific surface warfare for 18 months. Type 93 Long Lance delivered simple message. Accept technical risks if benefits provide decisive advantage. Invest whatever resources necessary. Train personnel to extreme standards. Persistence overcomes engineering challenges. From Tassafaronga to Surigao Strait, distinctive absence of torpedo wakes marked Japanese technological achievement that temporarily reversed naval power balance. 64 torpedoes launched simultaneously into darkness, traveling 22 miles without warning, destroying 4 heavy cruisers before Americans even knew they'd been targeted. Pure oxygen propulsion, 1,080-pound warhead, 49 knots maximum speed, 0 wake visibility. The weapon Germany didn't develop. The weapon Britain didn't develop. The weapon America didn't develop. The weapon Japan developed, and used a devastating effect until American adaptation, an overwhelming industrial power, negated technological edge. Type 93 Long Lance. Weapon U.S. Navy never expected. Weapon that changed naval warfare. Weapon that demonstrated technology alone cannot win wars, but can provide edge that turns battles.